All right, good morning, astronomy, my dear juniors and seniors. I hope you guys are doing well. Sorry, I'm trying to get situated. I thought I was, and then I wasn't, as you can see. Anyway, I hope you guys are doing well. This is going to be your notes video for this week. We are going to be looking at galaxies. I almost feel like I need to insert some sort of Star Wars joke here, like something about in a galaxy far, far away, you know? But anyway, I hope you guys are doing well. Your homework sheet that I sent home for you will correspond to this section of notes that I'm getting ready to cover. You also need to be working on your test project, which is an interview with a nebula. So hopefully that is going well. Do not wait until the very end of next week to do that project. It would not be wise. All right, it is a test grade. So hopefully I eased up a little bit on the amount of work this week in an effort to help you have time to do that. So please don't sleep on that project. Make sure you get it done. So we're going to talk about galaxies this week. We're actually going to just look at galaxies in general this week. Next week we're going to look at specific galaxies. Anyway, a galaxy is a gravitationally bound collection of approximately 100 billion stars, gases, dark matter, and dust. Now, it's impossible to count every single star and every single thing that makes up a galaxy. Hence the word approximately. Galaxies are always very distant and hard to view. And there are 4 types of galaxies. We're going to break those down and learn about each one of them. There are spiral, elliptical, lenticular, and irregular. So spiral galaxies first. All right. Spiral galaxies are disc-shaped with a brighter bulge at the center of the disc. Think of like a frisbee with arms. It's kind of what they look like. The center of the bulge consists primarily of red stars, and the spiral arms are composed of a mixture of red and blue stars. So it's a good mixture of warm stars and cold stars, quote unquote. I mean, obviously, all stars are warmer than what we would ever be able to touch or deal with, but warm stars and cold stars. Subcategories, there are 2 categories. You have a barred spiral galaxy or an unbarred spiral galaxy. And a barred spiral galaxy have a bar going across their central bulge. Now it's not a literal bar that you would put to maybe block a door or something like that, but it looks like a bar running through the bulge. And then unbarred are once known as normal spirals, but these are galaxies without bars. Okay, so they used to just be called normal and barred, and then they changed it to unbarred and barred. Classifications: spiral galaxies are classified based on the ratio of bulge size to the disk. So how big is that center bulge versus how big is the disk? Okay, so a couple types here. We have type A, which has a large central bulge compared to their disk, and their arms are tightly wrapped. So these ones are more compact, okay? The arms are tightly wrapped, they're close in to the center of the galaxy, but that bulge is pretty large. We have type B. These are intermediate between type A and type C. So these are your where was I going with that? My brain had a thing, something in relation to Goldilocks. Not too hot, not too cold, you're just right as far as galaxies go. Well, spiral galaxies go. Anyway, type C have small central bulges relative to their disks, and their arms are wide open. Class D, these have a very wide open barred spiral galaxy with a tiny bulge. So not only is the bulge smaller, but they have a bar that runs through them. And then if a galaxy is barred, it will be designated with a capital B. If it is unbarred, it will have a lowercase b next to it. So if you are ever studying galaxies in depth and you see a capital B next to it, then you know that it is a barred spiral galaxy. If you've seen one with a lowercase b next to it, you know you're working with an unbarred spiral galaxy. If a galaxy is in between the two classes, it will be designated with 2 lowercase letters. So maybe it is not quite a full bar, but it's not an unbarred galaxy either. It has the hinting of a bar there. It's classified with 2 lowercase letters. Okay, types. Types of spiral galaxies. 2 types. You have grand design spirals. These are galaxies which have well-defined spiral arms that can be traced continuously from the core to the periphery or from the core out to the outer edges. You can very easily follow these arm traces. Versus flocculent spirals. I like saying that word, flocculent. It's a fun word to say. Anyway, these galaxies have patchy traces of spiral arms, but the arms cannot be traced continuously from core to the periphery. So basically there are, I don't want to say chunks, but there are spots where there are, well, I guess chunks is a good word for it. There are chunks of missing stars in the arms, okay? But the arm will continue for a little while, then there's this break, and then it will pick up and continue on later, all right? Elliptical galaxies. Most galaxies are actually considered to be elliptical, okay? Most of them are not spiral, lenticular, or irregular. Most of them fall into this elliptical category, okay? But the reason for this is because their basic shape appears to us in the sky as an ellipse. Their true shape is believed to be a prolate ellipsid. And if you know your geometry, you know what that looks like. I should have put a picture of it in here. I didn't think ahead and do that. I'm sorry. But you can look it up online. Google it. It's there. These are designed with a capital letter designated, not designed. Designated. I was wrong. Sorry, guys. It's a struggle this morning. I haven't had any coffee yet, so I'm plowing through this here. I'm trying. Anyway, these are designated with a capital letter E, followed by a number from 0 to 7. Now, the number shows the degree by which they deviate from a perfect circle. This is known as their eccentricity. All right, eccentricity. So the number shows how much they deviate. A perfectly round one is an E0, and a highly stretched one is an E7. So the smaller the number, the closer it is to a perfect circle. The higher the number from 1 to 7, the more ovular shaped it is. Or ovular? Ovular? I think it's ovular. Elliptical galaxies tend to be smaller and less massive than a spiral galaxy. And they do not have a lot of interstellar gas and dust. They are primarily composed of red stars. So because they are lacking that interstellar gas and that dust, new stars aren't formed as easily in these galaxies, all right? Lenticular galaxies, these are a blend between an elliptical and a spiral. The best way I can think to describe their shape to you would be a football or an eyeball, okay? That lenticular shape, okay? They look like an E7 elliptical, but they contain a definite disk like a spiral galaxy has, okay? So a spiral has a definite disk, but they look like that very elongated elliptical. They have no trace of spiral arms in their disk, hence why they are a cross, okay? They have the bulge, but they don't have, they have the bulge, but they don't have the arms. And because they don't have the arms, they're actually pulled out. And then irregular galaxies, the last type of galaxy we're going to talk about. The term irregular is used to define galaxies that don't have a symmetry or a symmetric or well-defined shape, okay? So if you notice in science in general, not just astronomy, but in lots of the branches of science, if something doesn't have a definite shape, they slap the term irregular on it, okay? And this is true for these galaxies. They don't fit into one of the definite categories of spiral, elliptical, or lenticular. They don't clearly fit, so it's irregular. Their physical characteristics are closer to the disk of a spiral galaxy than an elliptical, but again, they don't clearly fit any of those categories, so they give it the term irregular. There's a large amount of gas and dust and blue stars in these galaxies. They have no central bulge and they tend to be small, but because there are large amounts of gases and dust, they can easily make new stars. Some subclasses here for you. You have IRR1 or irregular 1 galaxies. Something in my eye. These are galaxies that have a trace of a spiral structure, but not enough to be classified as a true spiral. Okay, so it kind of looks a little bit like a spiral. If they really wanted to, they could classify it in there, but it's not quite enough. So it's put in the irregular 1 category. And then irregular 2, IRR2 galaxies. These galaxies have no trace of a spiral structure, and these are very rare. And then you have dwarf irregulars, or DIIRs. This is a newer subclass where the spiral appears to be formed from dwarf stars. This is actually a subclass that they are still doing a lot of research on, still developing what the exact definition of it is. So I believe, that is the last note for this week. Next week we're going to pick up with named galaxies, specific galaxies that man has discovered and researched and learned about, as far as like our Milky Way galaxy, the Andromeda galaxy, different galaxies we're going to be looking at. But anyway, I hope you guys get these notes down. Remember to keep up with them. Don't fall behind on them, because when you come back, I'm going to check them. I hope you guys are having a good week. I miss you all, and I'm praying for you all.